Okay, the following is a video over 11.4 notes. And this is over the areas of regular polygons and composite figures. This is kind of something that'll pop up on the ACT, so I want to make sure I go over it with you so that you have some techniques to do this. The first one I want to show you is the formula for the area of an equilateral triangle. And when I have an equilateral triangle, I know that all my sides are congruent and that all of my angles are congruent. And that's going to be the same case over here, that all my sides are congruent. But I want to show you a specific formula for the area of an equilateral triangle. What I want to do is I'm going to call this length base, B, here, okay? So if this is length B, then I know that all the other sides are length B as well. Now, what I can do is I want to find the height of my triangle, okay, my height. Now, what I know about this new right triangle that I have, I know that this angle measurement here is 60 degrees. And I know that this angle here is bisected by my height to give me 30 degrees, okay? Now, I've got a few things that I know about this. I know that given a right triangle, let me show that this is a right triangle here. If I have a 30, 60, 90 triangle, okay, I know that this is length S, I know that this is length 2S, and I know that this is length S times the square root of 3, right here. So if I know that 2S is equal to my base, if I wanted to solve for my base, I would just divide by, or solve for S, divide by 2. I get that my S length, this length from here to here, is my base, is half of my base. So I know that this length here is B sub 2. Okay, so if this is B sub 2, I know that my height is equal to S times the square root of 3. So I can take B over 2 and substitute it in for S. And I get that my height is equal to B over 2 times the square root of 3. Now I can multiply, these are just fractions, I'm going to multiply them together, so I get my height is equal to b times the square root of 3 all divided by 2. Okay, and this is going to work for every equilateral triangle, that's why I'm showing you this. So then my area, we know, is 1/2 times the base times the height. Now I have my height in terms of my base, meaning that b is my variable and it's equal to my height. So let's kind of sub some values in here. I'm going to get 1/2 times my base, and this is b, I'm going to put that over 1. And then I'm going to multiply by my height, which is b times the square root of 3, all divided by 2. So then I get that my area is equal to 1 times b times the square root of 3. Well, b times b is just going to be b squared times the square root of 3. And then my denominator is going to be 2 times 1 times 2, which is going to give me 4. So this is a formula for an equilateral triangle. Okay, and you'll encounter this, and I want you guys to use this formula. That way you don't have to figure what this is using, you know, Pythagorean theorem and all that kind of stuff. We can come up with a formula for this that'll just work every time. Okay, now over here, this is a regular polygon. Okay, meaning that all my angles are congruent, all my sides are congruent. Okay, and I have some lengths here that I want to talk about. And the first thing I want to talk about is I'm going to call this length from here to here length S. Okay, and S is equal to, is the side length. All right, side length. All right, I'm going to call this value here my radius. Okay, you can think of it as a radius. It's the point that's furthest from the center. All right, so R, we'll call that the radius. Okay, and then I have this other value over here, and we'll call this length here, the length from the center of your polygon that's perpendicular to your side length. I'm going to call that A. And A stands for, get this one, and it sounds kind of weird, but I call it the apothem. Now, whenever I say that, it sounds like I have a lisp and that I'm saying opossum, but I'm really calling, it's really called the apothem. And so I have these three values, and then I have a final one, and that's just the value for n. and n is equal to the number of sides, okay? So we've got quite a few variables here. Make sure you write these down and you know what these are. And given these, you'll be given just one of these to find the area of the polygon. And I'm going to show you kind of a shortcut. There is a way to do it that works for everything. But what I realized is that that involves quite a bit of work to given one of these to solve for the other variables. And so I'm going to show you a couple, three different formulas that you can use to find the area of a regular polygon, given either the side length, the radius, or the apothem. So let's say that you're given the side length first. All right, so let's say that you're given the value for s. All right, you're given s. So let's say that your area, given the side length, is going to be s squared times n, the number of sides, divided by 4 times tangent of 180 divided by the number of sides. Okay, and if you use this, if you plug in s and your n value, and you plug this into your calculator, it'll give you the area. Okay, now let's do it for the radius. Okay, let's say you're given the radius. So if you're given r, your radius, then your area can be calculated as such. And you would say that your area is your radius squared times the number of sides times sine of 360 divided by n, the number of sides, and this is all being divided by 2. Okay, so you can find, if you're just given the radius, this length here, that you can find what you're looking for. You can find the area. All right, now let's say that you're given the apothem. So given your a value, the apothem. So if you're given a, the area is equal to the apothem a squared times the number of sides n times tangent of 180 divided by n. Okay? Now, guys, I'll be straight up with you. These are things that you aren't going to just readily remember. So when you are working on this, make sure that you have these formulas out, because it will help you do the problems. Okay? Now, I'm going to stop this and make another video for the notes. But please use this to help guide you through the next part.